Hello and welcome to today's webinar on active electrical cables. My name is Priya and I'm the marketing lead here. So today's talk will be about 20 minutes or so, followed by Q&A. So if you have any questions, please feel free to type them in the chat box or in the Q&A box. As always, we are recording the webinar and I'll be sending a link out to all the attendees in an email in a day or two. The recording also is available on our website. I'll drop a link to it on the chat box. Now let me introduce you to the speaker, Rich Whitty, Sales Manager at VTEX. Rich graduated from West Point in 1987. After serving the Army, he started on a career selling capital equipment for the semiconductor industry, specifically ion beam milling equipment and ion implanters. Rich has many years of technical and sales experience in other companies, and he joined VTEX last year. Now over to Rich.
Hi, thanks for joining us today on the 23rd of February. I appreciate everybody's interest in active copper cables, also known as AEC, active electrical cables. Today we're going to talk about the VTEX 200 gig and 400 gig active copper. So what we're doing with the active copper is we're using signal conditioning, basically amplification and equalization, and also changing the modulation of the signal, the electrical signal, to extend the reach of the direct attached copper signaling, and also, in addition, serving as an AOC replacement. That's active optical cable replacement. Some of the things that we get with this direct attached active copper cable are 4 nanoseconds latencies, BERs of 1E minus 15, and low power consumption, basically less than 5 watts per end, even at the 400 gigabit bandwidth level. So as you can tell from the slide here, we have up to 5 times the reach, which of passive copper, which also basically is better bending radius through lower diameter copper, lower weight, and lower power consumption than AOCs. It also has DDM, digital diagnostic monitoring, which includes looking at DC offset and phase calibration for BER monitoring. And I will talk about how we do that throughout the presentation. If you have any questions, please go ahead and put them in your question box, and we'll hit the questions at the end. So just a couple of highlights here. We've extended the reach of the copper to 7 meters. The form factor is QSFP, double density. It has 8 lanes of PAM4 modulated, 53 gigabit per lane. Through the I2C interface, we could take a look at a number of things. The management protocol, we do have CMIS 3.0 and CMIS 4.0, and CMIS 5.1 will be coming soon. You can look at some of the gauges here, but basically we're looking at anywhere between 34 and 26 AWG, and we have a slide at the end if you're interested in the specific gauge as per length or per data rate of the cables. One of the things that is interesting is that we have a simple design, and we don't use a digital signal processing chip. We have a single CDR, which is analog, and it drives multiple lanes. And getting rid of that power-hungry DSP serves for lower power consumption of the cables, which is important if you have data center applications. There's kind of a block diagram here. I'll give you a second to take a look at that, but you can see that there's that single CDR with the multiple lanes, and that's the 200 gig product that we're showing there. Let's talk a little bit about bit error rate measurements. We have a design where we're constantly monitoring for bit error rates. And to simplify it, basically what we're trying to do is we're taking a look at the open eye diagram and we're looking for an optical sampling point. So we're looking for basically max separation and the highest voltage. And we lock in on the phase angle where we get that best data. And we do that during warm up. So it's kind of, you know, it's a pre-test. So during warm up, we calibrate the phase angle. Once we have that phase angle calibrated, we're looking for what I will call a decision threshold. And if you look to the right side of the screen, you can see some complicated graphs which talk about the decision threshold. But basically, what it's looking for, it's looking at that voltage and the separation. If that separation or voltage changes to a certain extent, that decision threshold will assert looking at a change in the phase angle. And the way we do that is we do that almost through a lookup chart for environmental data, because we find that most of the shifts that we get are through environmental data, mostly temperature. So a little something about bit error rate calibration. The bit error rates are pre-FEC 1E minus 8, and post-FEC is 1E minus 15. Those are pretty good bit error rates, some of the best-in-class bit error rates that are available. Here's just basically showing you some gauges based on your length of your cable. And you can see some of the bit error rates. Those are pre-FEC bit error rates. Post-FEC bit error rates, once again, are 1E minus 15. And some things that aren't mentioned here, but I brought it up in the beginning, is that the latency is 4 nanoseconds, which is pretty good, especially if you're dealing with lots of transitions between going and getting data and returning data. So with that, I'd like to know if there are any questions. It's a fairly short webinar today, and I will also show you one of our AEC cables. This is a 400 gig cable. So you can see, I don't know if you can see the diameter of that is, it's short reach, but the diameter of it is less than a number 2 pencil. And if you're talking about passive active copper cabling, that could be twice the diameter, which would, you know, really prohibit you from populating the back of your boxes. And the bending radius would be severely hampered, so you couldn't fit this in or pack it in as you'd like to. So that's the extent of our webinar. It's a short webinar today. Are there any questions?
So I have a question. So the 400G passive DACs, what's the maximum length that it can reach? 400G DAC?
The rule of thumb for the passive DACs are at 400G. It's basically 2.5 meters. Anything longer than 2.5 meters, you really can't use a passive DAC anymore. You have to go to copper or go to AOC. And AOCs are going to be more expensive and have a higher latency than the active copper cables.
Okay, thanks, Rich. There's a question about AEC production? Have you ramped up to production of 400G AECs?
We are in our first production run now. We've just completed it. We've just shipped samples to our main customer for the product, probably 2 months ago, maybe going on 3 months. So we are shipping production cables. Before that, they were engineering prototypes, but we are in production runs now.
I also see a question about specifications or standards, actually. Can you see that? Do you see that one, Rich? Do you want me to read that out to you? So in the Q&A.
Okay. Is your cable compliant with the high wire spec? Is that what the one you're? So our cable is compliant with the high wire spec. It's, you know, we're not high wire, but we have basically the same, very similar specifications to the high wire. What standard do you comply to? Okay. That's a good question. Not being a product manager, I would have to talk to a product manager to ascertain the standards. I know the standards we talk about with the optical transceivers, but I'm a little, this being a kind of a new product for us, I'm a little bit less knowledgeable. But Jeffrey, I can find out and get back to you and let you know what the standards are. Okay, David at the beginning. Yeah, we've got some basic equalization, basically, you know, flattening out the sinusoidal waves for signal conditioning. And once again, we do that, and we're also changing that over from a NRC type of modulation to a PAM4 modulation. And I cannot reveal, anonymous attendee, I cannot reveal which chip we are using. There are some chip manufacturers that are out there, and you can, you know, they're typically tier 1 people. Will go ahead and just buy a silicon chip. We are really catering towards probably tier 2 people, where we are manufacturing the product ourselves. And so, you know, if you're a tier 1 person, you know, you're probably going to be in a different category. So you can take a wild guess as to which chips we're using. Okay, I think that's all the questions that are on the Q&A.
Yes, and if you haven't gotten to your question, we'll send you an email. Yeah.
So it was a short webinar. I appreciate everyone attending. If you have any other questions, please feel free to contact us at info@vtex.com, or my name's Rich. Telephone numbers up there on the screen. We're located in New Jersey. We've been in business since 2003. We are a New Jersey company, and look forward to being of assistance.
Yep. Thanks, everyone, for joining. I just want to say that we'll be at OFC in San Diego. So if anyone's attending, do stop by and say hello. Our booth number is 5039. So thanks again for everybody for joining, and have a great rest of the week.
Thanks. Thank you for joining. Bye-bye.